Hi everyone, this is Chris Olson from the ArduPilot organization, and this is the third video in a series on setting up traditional helicopters with the ArduPilot flight stack. And in the first video, we looked at the parameters for helicopters and what they do and how to set them. In the second video, we covered mechanical setup and setting pitch ranges and servos and so on. In this video, we are going to look at the throttle control system, which is called the Rsc, or Rotor Speed Control System, in ArduPilot. Originally, I was going to try to do this in one video, but I'm going to split this into two separate presentations because electric and piston and turbine engine helicopters are different. And so in this video, we decided to cover the electric configurations with mode 1 and mode 2. And in the second video, in the throttle control videos, we will cover the setup of the mode 3 throttle curve system in ArduPilot. So before we start on this one, there's something I want to go back to, which was from the second video. We're going to go to our H params here and take a look at H land call min. Now, I mentioned in that second video that setting this is very important. And it doesn't explicitly say so in the software here, but the setting is in PWM microseconds with a range of 0 to 500. Now, this is kind of confusing because usually when we think of RC pulse width modulated signals, we're thinking of signals that range from 1,000 to 2,000 microsecond. And here we have a range of 0 to 500. So let's explain this a little bit better. In this particular instance, we have this helicopter set at 100 PWM for that land call min. Well, what exactly is that in collective pitch? For the most part, you can think of this range as being from 0 to 1,000, and they're allowing from 0 to 500 to set this particular parameter. So you can look at 100 PWM microseconds as being, in effect, 10% of the collective pitch range. If it was set to 200, you can think of it as being 200% of the collective pitch range, and so on. In this case, we're setting it to 100. So what does that exactly mean? Well, let's take a helicopter where we have -3 degrees of negative pitch and say 11 degrees of positive pitch. So we have 14 degrees of pitch range with this helicopter. And 10% of that range is obviously going to be 1.4 degrees. So with 3 degrees negative, and we set this at 10% of that range, that land call min setting is set to -1.6 degrees of negative pitch. So I hope that's clear. You basically have to consider your total collective pitch range and kind of figure that as a percentage and do the math to figure out where that land call min setting is going to be active. But in this case, when the helicopter is landing autonomously, when the system reduces that collective pitch to -1.6 degrees, as determined by this setting right here, and it senses no further descent in altitude, the landing detector has already, it thinks it's landed, but it's not sure, so it reduces the the collective pitch to that value that you have set. In other words, it reduces that collective pitch down to minus 1.6 degrees. Everything seems to be static. That helicopter is going to disarm and shut down. So again, very important to have that set right. If you set it to the upper end of the range at 50% of the collective pitch, you're going to be having that come on at 4 degrees of positive pitch, and that could be fairly dangerous. Say the helicopter got caught in a little bit of a wind gust or something when it was landing and went into translational lift, so it refused to come down, and the system reduces that to the 500 value, which is 4 degrees of positive pitch, and it didn't come down anymore. It may shut your helicopter down in flight and cause it to have a sort of a rough auto rotation landing. So I just wanted to kind of cover that one again and give a little bit of information on how to sort of calculate that so that you can judge what to set that particular parameter to. Okay, so let's look at the Heli Rsc system here in ArduPilot. The RSC mode on this helicopter right here, you can see is set to channel 8. And we have 3 different methods that can be used for throttle control with helicopters in ArduPilot. We have the channel 8 input, which is typically called mode 1, and this is a RC pass-through mode. So your RC radio is controlling the throttle output. We have the mode 2, which is a set point. And well, before we start, let's just cover this one first. You can set. This is going to be used with helicopters with governors only. So if we set that to the set point, mode 2. Now we go to the RSC set point right here, 700 PWM. Again, this is 700 PWM microseconds on the throttle, which, you know, we typically think of that as being 1,000 to 2,000, but in this case it's 0 to 1,000 with the scaling used in ArduPilot. So at 700, we have a 70% throttle setting going to that governor in that helicopter. And it's really that simple. You can set this to whatever you want. If you want to run 85% throttle, just set it to 850 and save it. And when you set up your throttle switch in your radio to turn on channel 8, set channel 8 high, the software is going to use that set point that you just set, 85% throttle, and that is the only speed you will have, and the governor will accept that and set the speed accordingly. So mode 2 is really, really simple. Mode 1 is also designed for use with electrics with governors. I do not recommend using it with no governor and a throttle curve in the radio. And the reason for that is the RC failsafe system. If you have no governor in your helicopter and you're using a throttle curve in the radio and you lose the RC signal, what's going to happen? Your throttle control, the ArduPilot has no control over your throttle basically. It is going to be locked at whatever the last received value was from the RC radio. And well, depending on how much load the helicopter is carrying, depending on how fast you're flying it, and several other factors, that helicopter may or may not make it home without throttle control. So I don't recommend using the RC pass-through with a throttle curve in the radio for that reason. So this is primarily designed for use with governors. And the reason we want to use mode 1 instead of the mode 2 is that the mode 1 option with the RC pass-through allows us to change head speeds. And there's basically, well, there's kind of 2 different types of electric governors out there. We have Well, let's see. Governors, like typically used in aligned helicopters, the aligned governors. For instance, we'll take a throttle signal, and you can set up a switch in your radio with a knob to change it infinitely, and those governors will take that signal from the RC radio and convert it to a speed. You know, say you set it to I don't know, 80% or whatever, and the governor, if you enable the governor feature in that ESC, it will set a speed with that 80% throttle signal and attempt to hold it. And these type of governors, the speed generally decays a little bit as the voltage sags. You know, they don't hold it exact on the infinitely controlled ones like that. So that is one possible setup you can use is a switch with a knob combined with the switch, so you can adjust the output of the channel. The other type of governor that is in common use in electrics would be like the one that's used in the Castle ICE or ICE 2 series ESCs. And these type of governors have, typically they look for 3 different outputs from the RC to establish their speed. And we're going to go to the RC radio here to take a look at this. I'm going to kind of show what I mean here. I have to make some adjustments. I have to fire up my GoPro camera. And start recording with the GoPro. Okay, so we got the RC radio here. Hopefully we can focus on that screen. It's very, very difficult usually. We have reflections from lights. We got rid of that. The screen might be a little bit bright. I think we might have to reduce the screen brightness a little bit. Sorry about this. I should have looked at this before we started here. I'll reduce that screen brightness. I think that will make it better. And then we'll go to the servo outputs. Okay. We have an electric helicopter here with a Castle governor in it. We'll explain how this works, and this is very typical with a lot of 3-speed governors in helicopters. The throttle hold is basically the same. I mean, the channel 8 switch has to be configured so it turns the throttle signal on or off. And you can see that when I move a switch, I'm getting a different reading on this channel 8, the throttle hold I call this. This is actually the Heli Rsc System as far as ArduPilot is concerned. But you can see that I'm getting a different value there. And one of the things that I want to mention before we get too far into this is with electric helicopters, always make sure that you have the power disconnected to the speed controller or the motor or something to prevent it from starting. Electric helicopters can start on the bench. They're considerably more dangerous than piston or turbine helicopters that actually have to be started. And having a helicopter the size of the one we have sitting on the bench here accidentally start would be pretty much disastrous, because soft objects like humans, wood, that kind of stuff is not going to stop it. I mean, these things got a lot of power. And basically everything in the vicinity of that helicopter is going to be destroyed, and probably the helicopter itself, you know, if you accidentally started it on the bench. So make absolutely certain that the power is disconnected. And there's one setting in ArduPilot that I want to explain to never use with an electric, and that is the Hrsc idle parameter. Always make sure that this is set to 0 for an electric. Do not use it. This is only for piston and turbine helicopters, and any value you set that to will cause your channel 8 signal to be activated to the speed controller as soon as you arm the flight controller. And depending on what type of an ESC you have and where you would set that RSC idle to, you could potentially spool up a helicopter to full rated head speed and power without even throwing the throttle hold switch or the motor interlock switch. So very, very important with electric helicopters. The default in ArduPilot is 0 for that parameter, and very important for electric helicopters to make sure that stays at 0. The only way you could get anything different than 0 is if you set it. So always make sure that HRSC idle for electrics is not used. Now, going back to the radio, what the governor looks for on these 3-speed governors is that they typically have 3 program speeds in the governor that you can set, and these are called idle ups. And I think, let's see here, we'll go back to looking at the radio screen so we can kind of see what we have here, hopefully, and try to prevent reflections and so on the screen. This is a very hard thing to focus on. So looking at the RC radio, what the and we're looking at the throttle hold, or the channel 8 output, and this is the governor signal on my channel 9 here. Hopefully this focuses okay without reflections on the screen. So when we throw the throttle hold, or in ArduPilot parlance this would be the motor interlock, the signal output is approximately 50%. So what this type of governor looks for is a signal from about 10% to roughly 50% of the output. It's going to operate at the first speed that is programmed into the governor. When you go, and this is commonly called condition normal, so you go to idle up 1, and now the signal increased to 75%. And basically these type of governors look for a signal from about 50% up to around 95% to operate at the second speed that's programmed into the governor. And we switch to idle up 2, and now we're at 100% output on channel 8, and these type of governors look for a 100% output to operate at the third speed that is programmed into the governor. And we have the girl on the tablet complaining about the motor interlock being enabled. So that is the one advantage with the mode 1 over the mode 2, is that you can have pre-programmed speeds with this type of governor, like what would be in this helicopter here. It's a Castle ICE 160, and you can also program a knob with a switch to have an infinite output control if you want to use a governor that can use that type of output to infinitely change head speed. So that's pretty much it for electrics. It's actually quite simple. Just be careful with them. Accidentally starting one on the bench is not a good idea. And an RC failsafe, when you're using a governor, I should mention this. You should always configure your RC radio to hold the last received value on channel 8 with the ArduPilot system, and keep sending that value to the PICSOC in the event of loss of RC signal. With a governor, you just won't be able to change it with a mode 1. Whatever your last setting was, that's where the governor is going to hold the head speed on the helicopter. So it's not like you're flying without throttle control like you are if you had a throttle curve in the radio. But so that will work with the mode 1, but it will not work if you're using a throttle curve with mode 1, or at least not work all that well. So in the next video, we're going to look at setting up the mode 3 system, and that is considerably more complicated. It can be used with electrics without a governor, or it can be used with piston or turbine engines with or without a governor. So we'll be looking at that one in the next video. So there's actually going to be 4 videos in this series. And thanks for watching. We'll see you on video 4.